Hi guys, welcome back to the part two of the four-step system design framework, high-level design. We are going to continue with our design for the YouTube-like system with the requirements we gathered from step one. We will cover all the functional requirements as listed on the left hand of the screen and some of the non-functional requirements if they come along the way. This will save you valuable time so you can focus on the key components and constraints in the design deep dive. In this session, we'll break it down into three parts. First, about system components and their roles. Second, data flow from video uploading to streaming to recommendation and search functions. We need to make sure we cover all the area. And then last part is some design trade-off and key considerations. So let's get started. To meet all the functional requirement is listed here, but uploading. So let's start with some drawing to illustrate our thinking. So everything starts with the app or from the website. Given the volume, 10 million monthly active user, and upload millions of concurrent viewers, and also geographically, we need to support globally. So in this case, it's nice to have like load balancing. For load balancing part, if you are familiar with global service load balancing, you can generally mention that it is just an actual layer sit on top of the like regional or the load balancer set in front of the data center level. So this will be global server load balancing, but given our current scale, it may not be necessary, but it won't hurt if you mention that. And then for, let's say, each data center, DC1, we will have like, we will have API gateway. That is the entry point to our backend services. Okay, so let's put here just to make sure the interviewer understand you are trying to you're trying to adopt multiple DC or multi-AZ approach, and they are only illustrated in one data center as an example. So the other data centers will have the same design or structure. So we have API gateway. So API gateway, a load balancer, of course, will be just handling to distribute load to different different data centers or locations based on the configurations. It could be geo-based, could be connection-based, could be workload-based, etc. API gateway will be handle like user authentication, authorization, rate limiting, terminate SSL transactions, etc. Whitelist, blacklist, cached response. And for our design, can start with user services. Let's basically handle like all the user profile data, preference, all the configuration settings. Of course, it is storage. So we can generally mention it will be SQL or NoSQL, and what is the trade-offs. So in our scale, like for user information, I think it is well structured, and also we can do like queries for user segmentation, and it could be useful for recommendation services as well. So I think in this case, we can recommend using SQL. This is one of the cases like we can leave it to design deep dive, or we can spend a little bit of time to share our reasoning for this. So we don't need to do it in the design deep dive session. So cool because of like structured data. Um, complex query support. And in this case, we can also add like session management. As we're going to have everything as serverless as possible to support horizontal scalability. So this could be Redis. It's a good choice. or in some case, we can use it like a Cassandra or Dynamo, like as a high throughput data storage. And then one big part would be the upload service. Let's put it here. Let's reorg gateway. So when the request comes in, go through the API gateway, call it the upload service. We'll return, like, of course, we'll validate the request and the response with present URL for the actual video upload. Any object storage could be working here. We can do our own. We can use like existing cloud services like S3 or Google Cloud Service. So it's literally object storage. So user can upload directly to this with the present URL, which handles authentication. Yeah, it's required from the upload service. And here, I think we have covered a little bit about resumable upload for large files. Yeah, quick down into small chunks. And to guarantee the integrity and also like make sure we have the final verification of every part is successfully uploaded, we can like use like a checksum, which is the typical approach to check the integrity. For each chunk, we can add a checksum. Also, we can add the sequence number for each chunk, and then we can let the server know upfront about how many chunks we're going to upload. So with the sequence number, with the number of chunks, and also with the checksum for each chunk, it will be guaranteed like we upload all the part successfully. And we, of course, indeed, we can have in the final call, we can include the final upload information to make sure we uploaded everything. And then when the object storage receives the data, we need to make sure videos are processed and stored. So in that case, it's about like video can be uploaded in different format, supporting for different device or in different quality. We need to have like a backend process to process the video into a different format, different bit rate, and also we can do a series of check-ins like a copyright, harmful content or inappropriate content. So that means message queue would be the good choice given we are processing it in parallel, and also depends on the workload. We might need to scale up the processing part separately. So in this case, we need to have a series of workers to handle the functionalities what I just mentioned. But different bitrate format, like thumbnail, if any watermark, content tag, filter. So as you can see, it needs to be scalable as well. And also we need coordinators to make sure like we can handle the not file by file, we can handle the different chunks by chunks, and then we need a coordinator to make sure there are workers to handle different part of this, and then we will make sure when it is complete, it will be uploaded back to the object storage. So it takes items from here. We do all the tasks. I don't think we need to go to all the details because it is a complicated process. We can create a dialect acyclic I think a graphic or something as called the DAG. It will go through the whole process to complete all the steps we listed here, and then the coordinator will be responsible to upload to make sure when we complete, we upload back to the object storage. So that means the video is available in different formats, different quality. Now we can serve that to our user. So in order to serve to our user, normally we won't do from our server side because there will be latency. The data center could be far away from the user. A common approach would be like using the caching, which is content delivery network up front the object storage. It'll be uploaded here. And once the user requests the video, it'll be served directly from the CDN instead of from the server, from the data center. So CDN, to use CDN, there's a cost. It's not free. Even if you build it yourself, there's a management cost, there's operational cost. Also, yeah, it's a cost for data center. So we need to be careful about this. So think about like time to live on the eviction policies, least recently used or least frequently used, to save cost. I think that's pretty much the main reason. And also like save space to serve like most relevant or most popular content to the user. That's other consideration areas. And then when the user, and also for the metadata, I think user can upload directly, of course, through the load balancing, through the PI for the metadata into have storage. This will be like tags, title, time, author, etc. I think again it is quite structured data we can use SQL like storage, like MySQL or Postgre to store this kind of information. Okay, and then once the workers complete the work, it can also send a notification to the upload service. And the upload service can update the metadata to mark like the video as available from this moment on. And for each storage, of course, it's going to provide like availability and reliability, which means like we can, in case of if we only have one server, that will become like a single point failure to have database replication. And also if the data storage is getting really big, we need to consider about like sharding. In both of the case, like a video ID or user ID would be a good choice for sharding key. So to ensure like we have the reliability and availability requirement. So it'll be replica and a different shard as well, just to illustrate for this. And then for the streaming side, yeah, one thing we need to notice about like viewing service. Let's leave the, okay, maybe let's just add it. We have the recommendation service as well. Search service. So when the user creates the view service or browsing on the home page, it will have a list of videos and then like provide a list of like video IDs, and then it will load the like preview image or the preloaded buffered video from the CDN directly from here. Mainly it's just a list of IDs and some metadata. And then the user can retrieve the actual content from the CDN server. And for the view service, let's see if there's another functional requirement before we deep dive into the recommendation service or the search service, what they do. So viewing video processed start, we covered that. Video user can upload video, we covered that. Streaming on different devices, I think we covered that. We can do some deep dive here as well. What is stored on the CDN and how the streaming actually works, or we can leave that to the deep dive as well. It's up to you, and maybe clarify with the interviewer, search and browse personalized recommendation. Okay, let's cover these last two bits first and see if we have time, always conscious about the time, how much time you spend on the high level design, because like the design deep dive is the main force for this part. That's where you demonstrate your experience and skills for system design and to cover all the non-functional requirement. So for recommendation service, sorry, showing the previous ones about like the hashing. Recommendation service, of course, you need to build the index based on like user profile, user viewing history, and the segmentation for the users. Fit category, for example, for me, software engineer, 30, 40 years old, would be having like compare with like other users in the same segmentation or the similar profile. So recommendation service, we need to think first, we need to have like a data source. There'll be a group of workers that will be pulling data from, let's say, conscious of the space, viewing history, like what type of videos or like tags, categories the user viewed, how much time they spend on that, any fast forward, fast backward, repeatedly viewing, etc. I think that's based on how personalized recommendation service works, and also about user group segmentation. So that would be based on that. And also, like if you are not applying for a role on data scientist or data processing, probably that level of information would be good enough. And of course, like a user profile. So again, this should be scalable. I pull the data and then feed the recommendation service. We could also mention normally would be AI machine learning model here for the training. Maybe we can do that. Feed to the model, and then as a result, feed to the recommendation service and everything. We could have two parts. Let's start the recommendation, both on hot, warm storage. And the view service will load this data. Hot storage means caching like with Redis for users who use the service frequently. We'd better cache their recommendation, the hot storage for fast response and low latency, and also for the efficiency of the cache hits. And for warm storage might be because could be like NoSQL database, either document or like a key value database, because like it is user key, user ID based as the key, and then the recommendation content could be structured, could be unstructured, but I do believe it will be changed. And also based on different user preference, it could be different. So NoSQL would be a great choice here. I think that's pretty much it. And then for search service, I think it's the same thing. Search service here, we would have like common approach would be what's the name? The Elastic Search, which is based on Lucene. If you are interested, you can go really deep into these areas. It'll be the same. It will be built inverted index with the data point, provided we can see we have a bunch of workers to pull data from metadata service. Where is this? Yeah. And then build the inverted index, the feed access service, and then here again, we can have some popular search results. So we don't have to call the Elastic service every time when we have a request came in. If it's there, we just get it. If not, we call the service, pass on the query, and return the list to the user. The user can load the actual content from the CDN. So I think for the high-level design, that's pretty much covers everything. Now we need to just hear about like what CDN that would be. We can stream the video from here. Stream video with special tokens designed to optimize video streaming over internet. You don't need to know the details, to be honest. But if you're interested, there will be like a different file format, like HTML5 or the Google provides something as well. So I don't expect, or the interviewer wouldn't expect you to know that. Again, only if you are applying for like streaming service senior position, like you might expect to know this. But for a general system design interview, I think you can generally mention, I believe, or I assume there would be special protocols to handle the video streaming because the content is very specific and also is different from the general HTML content on the internet, and so adaptive. I think there's enough functional requirement. Yeah, video should remain accessible even if data center fails. Also, I think one network is congested, so it's adaptive streaming, which means it can pick the format that be suitable for the user device, and also it can pick the quality suitable for the current network condition or the user specific settings. And how it works is so for each video, it will have different format for each different format, and have different bitrate. And also, maybe we can add here, it will be chunks. Each chunk would be like 2 to 5 seconds. Probably that depends on the actual use case, but we are expected to suggest it is like divided into small chunks because it's fast forward, fast backward. There is like a buffer, etc. We can't just load the whole content for the video. It may take like a few minutes at least before the user can view. We need to make sure like it is streaming. So it's important we point out the video will be divided into chunks. For bitrate, yeah, for different quality. So that's pretty much it. When user request, they can specify like the video format on their client side, and also the bitrate they would desire, depends on the traffic volume and of course the chunks and offset. So the streaming service can provide the response with the requested content. So at this stage, I think we have covered all the functional requests and part of the non-functional requirement. Clarify with interviewer if you need to do like one final walkthrough about all the functional requirement from the request going through the load balancing. Yes, here I think would be wrong. Load balancer first, local load balancer first, then API gateway. And then with all this covered, the next step would be to cover the non-functional, to focus on the non-functional requirements, which I will introduce in the next video. So thank you very much for watching. See you next time.